Okay. Today we'll start lecturing on reverse engineering. So our main topic of this today's lecture are reverse engineering and re-engineering. So consider one situation, and that is a very unexpected situation. For example, we have developed one project of Java, but accidentally before the night of the submission, the day before yesterday of the submission, so your Java file actually got deleted. So in this situation, what we actually plan to do, or so we'll be definitely lost. But there are some situation, for example, since you have deleted your Java file, so if you already compile your Java file or project, definitely you have created some .class file or your bytecode. So you can run your project. So by running your project, somehow you can revert to your main source code. Definitely it will take time, but you will get some idea that uh, how is the nature and what are the input, what are the output, and what are the overall behavior. So this thing actually kind of is defined as reverse engineering. For example, we have your one existing project. From that project, if you want to understand or develop some project, so this is called reverse engineering in terms of software engineering perspective. So this is one very simple software development process model. So it is called waterfall model. So what do we do actually in waterfall model? In waterfall model, first we actually collect the requirement, then we perform the design, architectural design, then we implement, and finally testing and maintenance. It's a very common. We have heard this software process model 100 times maybe. So now the flow that we are currently watching, this is our normal forward engineering. First, as we have seen the waterfall model, requirement, design, source code, and behavior. And the reverse engineering, actually, it goes just reverse or opposite direction of our forward engineering. So behavior means how our project gives output, or how it be beneficial for the stakeholders who are using those. So by understanding those behavior, we might develop some source code. From that source code, we need to make some analysis or design, architectural design, logical design, or business rules, and many other things. Finally, we find our requirements of the specific domain that we are developing that application. So this is one abstract idea of what is reverse engineering. For example, we have one legacy system, or maybe one system that is already lost, or we want to investigate some system that is our interest, that we want to analyze. So this is actually considered as our old system. So from that, we can investigate the abstraction. Abstraction means different modules, ideas, input, output, functions, business rules. So these are kind of abstractions. So from old system, we usually investigate these abstraction by using the reverse engineering. So when the available module segments or understanding is with us, then we can re-implement the system that we plan to develop. So reverse engineering encompasses any activity that is done to determine how a product works, to learn ideas and technology that we are used in developing the product. If it is actually source code, for example, for maintenance purpose, over the time, we add some feature, we fix some bugs, or there's many activities performed over our project. So in course of time or over the time, it actually changed a lot of in terms of structure or in terms of the output or many other things. So source code is our actually last, what should I say, the shelter or the main reliable artifact or component from where we can actually identify our the nature of our system. So this is basically the reverse engineering. Reverse engineering can be done at many levels, in function levels, on application levels, or data flow level, or structure level, in many levels. So reverse engineering generally belongs to software maintenance. Yeah, in software maintenance, we just understand the code, we fix the bugs, we add some feature. So this is our main process of the software maintenance. So for understanding or fixing or adding these components, we should have a very good understanding of the system. So this is basically the part of reverse engineering. And that's why reverse engineering generally belongs to software maintenance area. Why do we need reverse engineering? So reverse engineering mainly is important. The first example that I have given you, that if you delete or lose any of your important project or information, then the reverse engineering is one of the ways we can recover our lost information. There might be some gap, but still we can have something. Something is definitely is better to get nothing. If you are very much keen or very much expert in that domain, I think it is possible to get majority of the modules or ideas from the by using reverse engineering. Assisting with the maintenance. So in the maintenance work, reverse engineering is important tool to find different anomalies or unexpected behavior. Even sometimes for example, sometimes we use different third-party apps. So if you consider in the education purpose irrigation system. For evaluating your assignments, there are some integrated with the, for consider, we have some third-party apps, maybe Turnitin. So if, say, sometimes if it doesn't work, so or it behaves or shows some anomalies, so we definitely follow the software maintenance work and find that maybe the license has expired of the irrigation plagiarism or evaluation system. So reverse engineering is one of the tools for assisting in the software maintenance for identifying anomalies. Even for migrating from maybe say COBOL or Fortran. So if you want to migrate in a new platform, maybe Python or Java, then we must need to understand our source platform, even the target platform that we plan to convert. So it is also play a good role for this migration task, the reverse engineering. Even facilitating the software reuse, sometimes we have seen in our legacy system or old system, some components can be reusable. So we definitely understand that part. We understand the logic. So that's why we need the reverse engineering thing. For example, a payment gateway in an e-commerce system, we can use in a new technology-based e-commerce system. If it comply with our current requirement, definitely thus reverse engineering thing will help us to reuse our software component. So these are main benefits of using reverse engineering. The first benefit, maybe we can say maintenance cost saving. For maintenance, it's a very difficult task. If our system is very old and we need to maintain before we are developing a new platform or system. So reverse engineering will help us to save some cost. Even for improving the quality of any system, our source code may be very poor, we need to restructure it. Then understanding system is important, that can be done by reverse engineering. Even competitive advantage, if we find some good application or an application from our competitive stakeholders, not stakeholder, you can say competitive counterpart who are using the similar software. So we can analyze those software. We can understand their strength or weakness by using reverse engineering. And if it is really helpful or the strength is very important, then we can integrate it our system. Software use facilitation, as I just previously explained, that maybe payment gateway or attendance tracking system in education management system. So these components could be reused. The primary ideas is understand the software system by reverse engineering. Definitely, there are some difficulties for reverse engineering. For example, the gap between the problem and the solution domain. So we might have some legacy system, old system. So for the old system, we need to identify the requirements for our target new system. So there is a definitely gap between the solution that we are using and the current problem that we are using. Even there are some gap between the concrete and abstract system. So the main output or the final software product is, we are considering this is the behavior of any system that we don't know actually. So from that, we can make some concrete ideas. But to find that concrete ideas, we need some challenges. For example, the architectural issues, the business logic, and there might be some engineering constraint. There are some other issues for abstraction and the concrete components. So can you hear me? Okay. So another thing is the coherency and disintegration. If all the modules are very much scattered, so for example, in education management system, so enrollment, registration, admission, these module, if they're actually very much scattered, but there should be some coherency or consistency, but it's difficult to identify those from observing the behavior of a unknown system. And there might be some problem with the hierarchical and associational. Sometimes we might have some classes or some components, they have many overlapping features. It's difficult to distinguish the roles from one segment to other segment. So these are the actually thing we should definitely consider, and we should acknowledge ourselves that these are difficult parts for making any reverse engineering system. So these are the main scope and the task of reverse engineering. So as we know that for software maintenance, we change our program a lot in course of time. In a project, many people work, people come and people go. Time goes, memory fades. So there are many issues. So over this time, our initial source code and the source code now, it might got changed a lot. So in those cases, if we want to make some documentation of those source code, we want to make some redocumentation of the source code. So it is definitely a task of reverse engineering. Recovery of design approach and design detail at any level of abstraction. So there are different levels of abstractions. So abstraction means it's a overall high level thing. So from that high level thing, if you want to develop, we definitely go to the root level to make it good implemented counterpart. So recovery of the design approach, architectural approach, business logic. So this is also task of reverse engineering. Identifying reusable components and components that need to restructuring. So some when we develop a new system, we might be interested to use a part of other projects that could be reusable. So that's why we need to actually grasp the total idea. Even we want to make some restructuring of any part of the project. So in those cases, reverse engineering perform well. So recovering business rules, for example, I have the source code. If we consider any e-commerce system or education system, I want to identify so how it was priced or how the marks was given. If we observe the source code, we can find the business logic, how it was graded, in which part was what percentage it covers. So this thing could be managed by the reverse engineering. And the overall architecture of the system could be understood by reverse engineering. Discovery of abstraction. So for our large complex system, the components might be very much disintegrated or scattered. So the discovery abstraction is very important for maintenance purpose, to fix any bug or to add some feature. Even in the evaluation purpose, our program got changed a lot. Even a re-engineering purpose. So reverse engineering and re-engineering, those two are sometimes many persons say identical, but there is a major difference. Maybe we are going to describe much. So re-engineering purpose also, we need to discover or investigate the abstractions. So these are very brief levels of the abstractions. In the application, we need to understand the main concept of our project. We understand the strategy or business rules. So this is kind of one abstraction. If our understanding the requirement is a functional level abstraction, we may need to understand how data flow from which actor to which actor. So what are the important algorithms? How one are dependent with others? Even the implementation for source code, even the symbol table. So these are different levels of abstraction for reverse engineering. If we actually manage this abstraction well, we can make some independent module. Sometimes we make a monolithic project that actually mix with one module to other, and that becomes very difficult. So if we can make these things, this abstract level, very much independent from each other, is very good to get a shape or get a good project from just investigating the behavior of any unknown project. So here you can see that we have different approaches of this discovery of abstraction. One is reverse engineering and other is re-engineering. So in the reverse engineering, we first understand the architectural level, design level, and the redocumentation means we have different parts and whether it is human understandable. So it is a part of the reverse engineering. Actually, re-engineering is kind of before making some re-engineering, we perform the reverse engineering first. For example, we want to make any change in any part of a project. So to making any change or improvement, what we need to do, we first understand that part. So for that understanding, we must need to use the reverse engineering. So based on that understanding, when we perform some engineering thing, say forward engineering, that is basically called re-engineering. So for re-engineering, definitely our primary task is complete the reverse engineering. So these are different applications of reverse engineering. For example, modifying software, change of any environment, platform, redesigning software, they're very prominent problem, Y2K problem, currency conversion, design and implementation of forward engineering in terms of, say, debugging if you want to investigate the bugs, program comprehension, even program visualization, even using any component of the software. These are the major applications. So this far we have checked the code reverse engineering. Code reverse engineering means actually in industry or organization where business are mainly maintained, they usually use information systems. So in the information system, they use both code reverse engineering and even they use the data reverse engineering. In the code reverse engineering, actually people try to understand how this source code actually work. This is actually code reverse engineering. So in information system, what information we are processing or what information we are storing, this is actually based on our data reverse engineering. So data reverse engineering focuses on the data and the data and over the problem that we are dealing and how these data are related with each other within the program, even in the database. So this is actually usually we consider that maybe code reverse engineering is much important, but nowadays data reverse engineering is getting a lot of exposure and getting it interested. Other RE term, reverse engineering term, or re-engineering terms for redocumentation, even restructuring, so transforming from one representation to another while preserving its external functional behavior. So very few recent, we used to use the old PHP system. Nowadays, people are using Django or other related competitive environment, Django, Python, and these are so the restructuring, the transformation from one platform to other platform is very important to maintaining the functional behavior. We just transform from one platform to another. So this is also our reverse and re-engineering part. Retargeting, transforming and hosting or porting the existing system in a new configuration. For example, you plan to deploy in maybe the Windows platform from another platform. So it is also important whether it would be compatible, and there are many other issues for transforming or transferring from one target to another target.